Hello, today I'm going to talk to you about modeling fraction division with bar models and also leading into the standard algorithm of dividing a fraction by a fraction. In 5th grade, students started dividing whole numbers by fractions. So along the left side of the screen, you will see there is a series of problems I set up to kind of develop a pattern with students. So the first thing that you'll see, your first problem, is 1 divided by 1/4. So another way that I would word that to my students is, how many 1/4 pieces or portions are in 1? So if we're talking about like a candy bar and we're breaking it up into 1/4 size pieces. So looking at this is our model of 1 whole. I then put a model underneath to show what that 1 whole would look like broken up into 1/4 size pieces. 1, 2, 3, 4. So what I would do with the students, I would say, how many pieces, 1/4 size portions, do we see? 1, 2, 3, 4. There are 4 1/4 pieces in 1. Then we would look at the second model, and we would see that there are 2 wholes divided into 1/4 size pieces. How many 1/4 size pieces are in 2 whole pieces? Then we would count 1, 2, 3, 4, same as the one above, 5, 6, 7, 8. I would then ask students to see if they are starting to see a pattern. I would go then to the third problem, and I would say 3 divided by 1/4, or how many 1/4 size portions are in 3 whole pieces? And again, we would go and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. At this point, students should start to see this relationship, this pattern, that when we are dividing a number, a whole piece, into fractional size pieces, their answer is 1 times 4, 2 times 4, 3 times 4. So I'm breaking this into 4 pieces, breaking 2 into 4 pieces each, and breaking 3 into 4 pieces each. Again, 4, 8, 12. You'll see that there's this relationship where they are multiplying that denominator with their whole number. So then I would say, without a model, what would 5 divided by 1/3 be? Students would tell me that this would equal 15. 3 times 5 is 15. So I would say to students, what about 1 divided by 2/3? So if they gave me the answer of 3, I would ask them, so if we have 1 divided by 1/4, there's going to be 4 pieces. 1 divided by 2/3. So how many 2/3 are going to be in 1? We would be able to find 3. So then we would model this again. So again, I have my 1 whole here, and I want to break that up into 2/3 size pieces. So how many 2/3 are in here? This is 1 group. So again, we talk about that there's 1 group of 2/3. If I were to extend this and put another grouping of thirds, we would have another 2/3 here. But I do not have but 1. This is all I have. I have 1 whole piece. So we would not include this part of 2/3. So how much of the 2/3 is still here? This would be 1 out of 2 pieces, right? 1 out of 2, which would be 1/2. So we'd have 1 whole group and then half of a group. So what is 1 divided by 2/3? There would be 1 and 1/2 pieces of 2/3. Now let's look at that. How could I get 1 and 1/2 by looking and using this pattern of multiplying? Well, what is 1 times 3? 1 times 3 is 3. But then we have this 2. I want them to be broken up into 2 pieces. So I'm going to divide that by 2. What is 3 divided by 2? 1 and 1/2. So now that we've developed this pattern with the students, I would then start with a fraction divided by a fraction. So we're going to look at 5/6 divided by 1/3. So we're starting, our dividend here is less than 1. So I want there to be 6 parts. I'm going to bring this over. I'm going to make it a little bit bigger. And so how much are we actually starting with? What is our dividend here? 5/6. So I'm going to highlight this 1, 2, 3, 4, 5. This is what we are starting with. So when I look here, I'm going to label this as 5/6. Now I want to know how many 1/3 size pieces can fit into 5/6. How many 1/3 size pieces can fit into 5/6? So I'm going to take and I'm going to break this into thirds. All right, so we're going to highlight how many fit. 1, 2. 2 whole times I can get 1/3. 1 and 2. But then if I look here, if I highlight this last piece, I do not have the entire whole piece here. I only have 5/6. So how much of this third is left? 1 out of 2 pieces, or 1/2. So we would say that 5/6 is divided by 1/3 is 2 and 1/2. So let's look at that pattern. That pattern before, we were multiplying to get our answer, right? Our answer here was 4, and then 8, and then 12, right? So we're going to look. I'm going to take this and I'm going to multiply. What is 5 times 3? 5 times 3 is 15. And then I'm dividing by that piece that's left over, 6. Okay, so how many groups of 6 are in 15? 2 whole groups. And then I would have 3/6 left, and another equivalent fraction for 3/6 would be 1/2. So this would lead students to be able to see that standard algorithm. So if I were to clear my screen, we have a fraction a over b divided by c over d. We were taking and multiplying the numerator and the denominator. Well, with multiplying fractions, if our numerator and denominator are across from each other, I'm able to multiply straight across. Students should be familiar with this from 5th grade. And then what are we going to have left? We divided by either the numerator or denominator. So we're going to keep this down here, and we're going to keep this down here. So what happened from situation 1 to situation 2? Well, if we look, this fraction and this fraction stayed the same. Our operation changed to the inverse. It went from division to multiplication. But then we also have an inverse of our second fraction. So our second fraction went from c over d to d over c, which is called a reciprocal. So students will then be led through this modeling to know that the standard algorithm for dividing a fraction by a fraction is you are going to multiply your first fraction, your dividend, by the reciprocal of your divisor, or the inverse of your divisor. So this would then be a times d all over b times c. Thanks for watching.